Good morning, chemistry students. Today I'm going to show you a little bit about some chemical reactions, give you an overview. You may already know a lot of this from middle school, but here we go. So first, what chemical reactions are. They are the process of chemical change in which you start with one thing and you end with something different. For example, if you have a campfire that's burning, you start with firewood and oxygen, and you end up with carbon dioxide and water vapor and ashes when you're done. The things that you start with in a reaction are called the reactants, and the things that you make in the reaction are called the products. So we write chemical reactions in one of two different ways. We can either use words, such as a solution of lead-2 nitrate reacts with aqueous potassium iodide to produce solid lead-2 iodide and a potassium nitrate solution. Or we can use a chemical equation form, which looks something like this. And when we're using this chemical equation form, a couple of things to note are that if the things on the left-hand side of this equation, this will open for me. Let's just try this way. The things on the left-hand side are called the reactants, and the things on the right-hand side are called the products. So the next thing to note is there's this thing called the law of conservation of mass, which says that in a reaction you can't create or destroy matter, it only changes form. In other words, however much stuff we start with is what we have to end with, because essentially a chemical reaction is like playing with Legos. You take things apart, you put them together, but you don't create new Legos and you don't smash your old Legos up whenever you're playing with them, if you're doing it right, at least. So all chemical reactions have to be balanced, meaning we need the same number of things on the left side of the reaction as on the right-hand side. So the number of atoms of each element of reactants and products must be the same. So for balancing an equation, we add what are called coefficients or multiplying factors out in front. So if we were trying to balance this equation, oh, that went too far. If we were trying to balance this equation right here, you may notice that over here we have our reactants, and then over here are our products. On the left-hand side, we have one magnesium, and on the right-hand side, we have one magnesium. But over here, we have two oxygens, and over here, we only have one. Now, we can't just put a 2 down here and make it MgO2, because the formula for magnesium oxide, since magnesium is a +2 charge and oxygen is a -2 charge, is just MgO. So instead, you have to put the 2 out in front. So you put that 2 right there. And then, of course, since you have 2 magnesiums on the right-hand side, you then have to go back and add another 2 on the left-hand side. And so that's how it's balanced. It's 2 magnesiums plus an O2 makes 2 MgOs. Now, the other thing you may be wondering is why oxygen has this little 2 down here. And that's because it's what's called a diatomic element. And you'll notice this as you get some more practice with this. There are 7 elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, that always occur in pairs and never just occur by themselves. So those are just a few things to note when you see those. So let me see if I can. These are sometimes called the deadly 7. So that may be something that you see. All right, in this video clip, I'm going to show you how to actually balance some chemical equations. So I have a fairly simple one here to start with, where we have aluminum plus oxygen makes aluminum oxide. And just a refresher, these things over on the left-hand side are called the reactants, and the things on the right-hand side are called the products. And the goal is to get everything on each side of the arrow equal to each other. Right now you can see we have 1 aluminum on the left and 2 aluminums on the right, and we have 2 oxygens on the left and 3 oxygens on the right. Well, solving for the aluminums is going to be pretty simple, but let's turn our attention to the oxygens because we have a 2 on one side, a 3 on the other side. So the way to get those equal is we're going to need some number to go out in front that we can multiply these numbers by so they equal each other. And so ultimately what we're looking for is something called the least common multiple. And the least common multiple between 2 and 3 is 6. So to get these equal, we're going to need 6 oxygens on each side of the arrow. Now, for the oxygen on the reactant side, the number we would put out in front to make it equal to 6 is a 3. Because if we have 3 O2s, that gives us a total of 6 oxygens. And over on the product side, the number we need is a 2, because that gives us 2 aluminum oxides, and each one has 3 oxygens. So that's a total of 6. But putting this 2 right here not only doubles the amount of oxygens, but it also doubles the amount of aluminums. So we now have 4 aluminums. So we need to go back over to the reactant side and put a 4 in front of the aluminum. So this is our balanced equation. Let's look at one that's a little more difficult here. In this one, our arrow is right here. And we've got calcium sulfate plus aluminum bromide makes calcium bromide and aluminum sulfate. So if we look, our calciums are equal on both sides. But we have 1 sulfate here, and we have 3 sulfates there. So the first step would be to put a 3 right there. And that gives us 3 sulfates. As you can just consider this polyatomic ion to just be one whole thing. That also gives us 3 calciums. So on this other side, we need to put a 3 in front of the calcium. Now, that gives us 3 calciums, but it also gives us 3 Br2s, or 6 bromines. So over here, where we have the bromine on the reactant side, we now need to put a 2 in front of that, which gives us 2 times 3 is 6 bromines. It also gives us 2 aluminums. And over on the other side, we have a 2 in front of aluminum. So that looks balanced as well. So our coefficients are 3, 2, 3. And then we don't need anything out here in front of aluminum sulfate. There's like an invisible 1 there. So for this one, we're going to look at one that's a bit more difficult. This reaction is a combustion reaction. We'll talk more about that tomorrow. But if we look at this reaction, it's got oxygen in 3 different places and hydrogen in 2 different places, with a lot of large subscripts down here, like a 10. So we're going to take this one step at a time. The first thing we notice is there's 4 carbons on the left and 1 on the right, so we'll just put a 4 out there. The second thing we notice with the hydrogens, we've got 10 hydrogens on the left and 2 hydrogens on the right, so we put a 5 right there because 5 times 2 is 10. Now for the oxygens, we have 2 oxygens on the left, and on the right we have 4 times 2, which is 8, plus 5. So we have 13 oxygens over here, because we've got 8 plus 5, which is 13 oxygens. So what times 2 is 13? Well, we can look at that and say, well, it'd be 6.5, or we could use an improper fraction in this case. 13 halves times 2 is obviously 13. So in order to simplify this, fractions are no good here. So what we're going to want to do is multiply everything in here times 2. And so when we do that, we're going to get a 2 right here, this 13 halves times 2 will magically become 13. This 4 will become an 8, and this 5 becomes a 10. So our coefficients are 2, 13, 8, and 10. And if you go through and double check everything, this equation is now balanced. So that one's a bit tough. Last one we'll look at is this one, where we have HCl plus calcium hydroxide makes calcium chloride plus water, where we had a hydroxide and then suddenly we end up with water. Now, to help us balance this, it may be better to consider water as being hydrogen hydroxide. If we do that, this may help us balance this a little bit easier. And if we do it this way, we'll notice on the left-hand side, let's ignore the hydrogens right this minute. We have 1 chlorine on the left and 2 chlorines on the right. So we put a 2 out in front of the HCl. And then we have 1 calcium on each side, calcium and a calcium. And then we have 2 hydroxides and 1 hydroxide. Well, if we put a 2 right there, that gives us 2 hydroxides plus 2 hydrogens. 2 hydroxides plus 2 hydrogens, and that takes care of the 2 hydrogens over there. So you'll notice if you double check, everything's balanced. We have 2 hydrogens plus 2 hydrogens, that's 4 hydrogens, gives us 4. And then we have 2 oxygens, 2 oxygens. Everything's balanced. So that is, these last 2 examples are about as tough as balancing equations can get.